Hello everyone! Today's our topic is photochemical smoke, chemistry of smoke formation in urban areas. So, what we will talk about today? The table of contents says that you will learn today what is a photochemical smoke and its difference from industrial smoke, give some historical examples and tell about source of pollution. In the main part we will consider chemistry of photochemical smoke, health effects, environmental impact, prevention and control strategies. In conclusion, we will sum up all the ideas that we said. Okay, what is a photochemical smoke? Photochemical smoke is a term that was first described in Los Angeles. So, let's get straight. What is a photochemical smoke? Photochemical smoke is a kind of cloudy haze that can be seen in big cities, especially in sunny days. This is not just fog, but a result of air pollution that mixes with sunlight. It appears where there are a lot of cars, factories, and people, and becomes a real headache for megacities. It is important to understand that photochemical smoke is not the same as the industrial smoke. Photochemical smoke that has been encountered before is the result of sunlight and pollutants. It is typical for warm climates. It's browner, drier, and loves hot, sunny days. Don't you notice that in winter it's kinda air cleaner? It might be because the sun is not often visible in winter. While industrial smoke is about direct emissions, photochemical smoke is all about secondary reactions. Industrial smoke is coal smoke and sulfur compounds. Its characteristic a thick, dark smoke, which is a wetter, grayer and thrives in cold, damp conditions, and doesn't rely on sunlight. Okay, about historical examples. Historical examples we consider Los Angeles. Los Angeles is a poster child for photochemical smoke. In 1943, Los Angeles residents first began complaining about haze and eye irritation, which was associated with increase in number of cars and exhaust emissions in sunny climates. Another example is Mexico City. Smoke has become a disaster due to its geography, a city surrounded by mountains which will still prevent ventilation and dispersion of pollution. And overpopulation also one of the reasons. The second example is industrial smoke, London. In London in 1952, great smoke covered the capital of Great Britain. In December, severe atmospheric pollution which led to mass deaths. Due to cold weather in autumn of 1952, the people of London tried to keep warm by burning more and more coal. The products of coal combustion and exhaust gas from cars remained near to the surface of Earth, creating toxic gray pulp. Harmful substances could not disperse in atmosphere, so it was dark as night in city during the day. The smoke lasted for about 5 days, and according to experts, directly and indirectly led to death about 12,000 local residents. The Great Smoke is considered one of the main major events that marked the beginning of global environmental movement. The sources of pollution are mainly human activities, we know, including urbanization. The main pollutants are transport, like cars, trucks, and buses. Factories also emit volatile organic compounds from solvents and paints. But natural sources are not exception. They also influence their formation. Examples are forest fires and volcanic eruption.
Chemicals present in photochemical smoke. First is tropospheric ozone. Tropospheric ozone is a secondary pollutant, which means produced by the chemical reaction between two primary pollutants, nitrogen oxides and volatile organic compounds. And second is volatile organic compounds. Volatile means having a low boiling point and easily converted to gas at room temperature. And organic is carbon compounds, for example, isoprene, methanol, and ethane. And here's some statistics. You can see that the main sources of emitting nitrogen oxides and volatile organic compounds are first road transport and energy production and the industrial processes. Okay, next, photochemical processes. The process of formation of photochemical smoke involves long chain of reactions, which is difficult to present over here, but we will simplify it. So starting with a vehicle emitting the nitrogen monoxide and volatile organic compounds, nitrogen monoxide will react with the oxygen radical in the atmosphere and gives us nitrogen dioxide, and which is in the presence of sunlight converted to dissociated into nitrogen monoxide and oxygen radical again. And oxygen radical, producing oxygen radical will react with the oxygen molecule in the atmosphere and gives us ozone molecule. And then nitrogen monoxide and the ozone will react with each other and gives us the nitrogen dioxide and the oxygen molecule. And this is, as you can see, this is the cyclic process, but in the presence of volatile organic compound, and all of this nitrogen monoxide and oxygen radical and ozone will react with the volatile organic compounds, which gives us hydrocarbon-free radicals. And hydrocarbon-free radicals are very effective, and then it will react with the nitrogen dioxide and gives us the main part of photochemical smog, peroxyacetyl nitrates, aldehydes, and other compounds. As the PAN and aldehydes increases, the photochemical smog also increases. And the next health hazards of photochemical smog. All the major constituents of photochemical smog are detrimental to human health and the environment, being a cocktail of chemical oxidants such as ozone, nitrogen dioxide, and the peroxy compounds. It's often termed as oxidizing smog. Firstly, the brown nitrogen dioxide in smog affects visibility. Nitrogen dioxide, ozone, and peroxyacetyl nitrates will affect the respiratory problems, and prolonged exposure to nitrogen dioxide lowers the resistance towards respiratory infections. Apart from being to the eyes and respiratory tract, some volatile organic compounds are to be believed carcinogenic. And ozone causes oxidative damage to plant and animal tissue.
How air pollution affects nature. Air pollution has severe impact on nature and the environment. One of the most noticeable effects is the damage to plants and the crops. Polluted air contains harmful gases such as the sulfur dioxide and nitrogen oxides, which weaken plants, damage their leaves, and they reduce food production. Farmers struggle with lower crop yields, which affects food supply and the economy. Another major concern is soil and water pollution. Toxic chemicals from factories, cars, and power plants settle on the ground and contaminate soil and the water sources. This pollution not only harms plants and animals, but also enters our food and drinking water, creating health risks for humans. One of the most serious consequences of air pollution is its role in climate change. Greenhouse gases such as the carbon dioxide and the methane trap heat in the atmosphere, causing global warming. As a result, we experience rising temperatures, extreme weather events, and the melting ice caps. In cities, pollution often forms thick layers of smoke, reducing visibility and making it difficult to breathe. The combination of air pollution and the climate change leads to serious long-term consequences for our planet. So, next one is how weather affects pollution. Weather plays a big role in how pollution spreads and stays in the air. One of the most dangerous weather effects is temperature inversion. Normally, warm air rises, allowing pollution to disappear. However, during a temperature inversion, a layer of air traps cold air below it, preventing pollutions from escaping. This leads to dangerous levels of air pollution, especially in cities. When pollution gets trapped close to the ground, people breathe in more toxic air, which causes health problems like asthma, lung diseases, and heart conditions. Another factor that affects pollution is wind and humidity. Strong winds can carry pollution over long distance, meaning that even areas far from factories or big cities can experience poor air quality. On the other hand, humidity can make pollution worse by creating new harmful chemicals in the air. For example, moisture in the air can react with pollutions and lead to the formation of ground-level ozone, which is dangerous for both humans and nature. Seasons also affect the air pollution levels. In winter, people burn more fuel for heating, releasing more smoke and pollutants into the air because the air is often still in winter. Pollution builds up and creates thick smoke in cities. In the summer, the hot sun reacts with pollutions and creates photochemical smog, which makes the air dirty and unhealthy. These seasonal changes show how pollution is influenced by both human activity and natural weather patterns.
We'll talk about how we can fight photochemical smog in our cities and wrap up our presentation. Smog is a big problem that harms our health and the environment. One of the best ways to reduce smog is to change how we travel. For example, many cars today have something that called catalytic converter. These devices that harmful gases from car exhaust into safer substances. Even better, electric cars are becoming more popular. Unlike regular cars, electric cars don't burn fuels, so they don't release harmful gases. If more people switch to electric cars, we will see less pollution and clear skies. And also, government and industries also play a key role in reducing smoke. Many countries have created strict environmental laws that limit how much pollution factors and power plants can release. These laws push industries to use cleaner technologies and install filters to catch harmful particles. So when industries follow these rules, they release less pollution, which means cleaner air for everyone. Next, we also need to think about how we produce energy. Burning fossil fuels like coal, oil, and natural gases creates a lot of pollution, which adds to smoke. On the other hand, renewable energy sources like solar and hydropower don't produce smoke and because they don't release harmful gases. When cities invest in renewable energies, they rely less on fossil fuels, which reduce pollution and smoke. This shift to clean energy also helps fight climate change. Besides this big change, each of us can help reduce smoke in small ways. For example, taking public transportation, carpooling, and saving energy at home all help lower air pollution. Recycling and reducing waste also cut down on the energy needed to make new products. Even planting trees can improve air quality in our neighborhoods. Every small action adds up and can make our cities cleaner. Let's take a moment to understand why these changes are important. Because photochemical smoke is created when harmful chemicals from cars and factories mix with sunlight and in the air. This creates a thick, unhealthy hair that can cause breathing problems and other health issues. By reducing the amount of pollution we release, we can stop smoke from forming. This means a healthier environment and a better quality of life for everyone. To sum up, there is several ways to fight photochemical smoke. First, using new technologies like catalytic converters and electric cars that cut down on harmful emissions. And second, governments and industry need to enforce strict environmental rules so factories and power plants reduce their pollution. Third, investing in renewable energy like solar and hydropower, which helps us rely less on fossil fuels and reduce smoke. Finally, each of us can make difference by using public transportation and recycling, also saving energy. And in conclusion, fighting smoke isn't just the job of the government and big companies. It's everyone's responsibility. By working together and taking small and smart steps, we can create cleaner air and a healthier world for ourselves and the future generation. Thank you for your attention. And the next list, we have our references. And that's all.